Okay, so I realized I wasn't recording when I was making this demo video, but so I'm just recording my audio separately. So I'm demoing my AI RAG project that I've been working on, which is a RAG pipeline, but it's a bit different. It's a temporary RAG pipeline, which I'll discuss later on. But so far, I have been working on the template extraction, which is essentially what I'm doing to it's my logic to extract text from any given document in a accurate manner. And so what the logic behind it is that for any different document that you have, where the structure is different, you would create a template for that. So if you have 10, 20 different types of documents, you would have 10, 20 templates. And of course, it may sound like it's not efficient, but it actually is efficient. And I did my research online, and this is one of the most efficient approaches to accurately extracting text from varying documents. It's easy when you're extracting text from the same document type and same document structure, but the moment you have varying format, it changes. So I'll go ahead and so I went ahead and actually started the template creator right here. So I'm just walking you through the different things here. So you have load PDF, you have clear boxes, save templates, load template, and browse templates. So load PDF, once you go click on it, it will allow you to select the PDF that you're going to create as your template. So what you want to select is an unfilled document, where so here, right here, where I'm showing you an unfilled document right here. And so what we'll do here is actually create a template out of this. And what this UI does is you essentially come here and you look at the specific areas that you want to be pulling text from, and you will be creating boxes around it. So if you go up top here, you'll see a box type. So there's three box types. There's general, there's table, and there's paragraph. And what you want to do is what you want to understand is general is best when you are not aware of what the layout is for the specific area that you're pulling text from. So if I where the cursor is, right, the fright charges area, there isn't like a table or like a paragraph there, right? It's more of a random layout. So in those scenarios, you would go with a general box type. So that's where the logic behind the general one is, you allow the code to understand like what the layout is, and it, does its best to accurately remove text from it. Then you, of course, you have a table box and you have a paragraph box. Table box is, if you're actually working with a table. So right here, I'm going to go ahead and actually draw a box around the area which I want to be pulling text from, which is this table. So all you have to do is just drag your cursor from one point to the other, and that'll create a box around that area. Then you can name it. And also just keep in mind that, when you're creating these boxes on this document, it is actually storing the order of the boxes that you create. So then when in the output, the text will be uh, provided in the same order as the boxes. So that's pretty good. So right here, as you see, once I selected OK, there's a bunch of lines that popped up, and these lines are actually what happened was that the code went ahead and visually detected using the OpenCV library where there are lines within that box. So you'll see red lines for any horizontal lines, as well as blue lines for any vertical lines. It also detects any differences in the background color, right? So that's how it was able to detect that there is actually a header row there, because technically that header row didn't have any lines, right? So it was able to detect the background change. So that's how you work with if you don't have lines. Um, so uh, yeah, so that essentially what it does now is it takes those lines and those vertical and horizontal lines, and then it will be creating cells out of that. It's pretty straightforward. The pop up here is essentially just something that's more of a debugging thing for me, where I'm able to adjust the line detection sensitivity back in the code. So something that's not something that I'll be keeping there. So not much to discuss. So you can go ahead and click OK and save that table, and there you have it. And so I'm just going to be repeating that for a few more tables for the sake of the demo. So you'll see that I'm creating boxes around all those specific tables right there. And down here, you'll see that specific area that I was hovering over is actually where usually you'll be having lines, not a table. So I went ahead and selected the paragraph box for that specific area. So in the paragraph box, what will happen is essentially we'll just pull whatever text is within that box and output it from top, bottom, left to right format, right? So paragraph box is pretty simple logic. And then down below here, this is a pretty big table, and this is where having that separate logic for working for extracting text from tables is very important, right? And not just having a general logic being applied for all boxes, because when you're outputting these tables, it's very important that the output shows the proper structure of the table, because this output is going to be used for chunking and then for vectorization, and then ultimately it's going to be used by an LLM, right? So you want to be making sure that the LLM is able to actually read the content properly, right? So it's able to use it as good context. Otherwise, as you know, bad input equals to bad output for an LLM. So I'm just going through the other boxes here. So if you look at the box at the top, clear boxes, that's just going to clear all the boxes and reset the template. So if you want to restart, if you messed up somewhere, you can restart. Save template will just save it. And then the last two buttons are something that need to be removed, so you can ignore those. So I'll be going ahead and saving this template. There we go. You can close this UI now, and I'll be going into my other file, which is going to be the actual extraction file. So that previous one was the template creation file. So now I'm going to be going into the template extraction file. Over there, you'll see me hovering over the demo template. So that template that we created is now saved as a JSON file. So now I'm going in and selecting a filled version of that same document, so we can see how it does in actually extracting the text. So I'm just going to be, I believe I'm going to now show you a filled version of that same document, just so you know how it looks. Right, so here's that same document, but as you can see, that I have actually went ahead and put text into it. So, you know, once you see the output, you'll be able to see all this text that we had inserted actually showing up in our output. And this is all mock data, by the way. So I'm now going to go ahead and actually start the template extraction. I'm going to come in here and select that filled document. You see below in the terminal, that was pretty quick. It was able to provide the output. So now I'm showing you here, what you see here is the actual output from that extraction. So you'll see the different tables, table 1, 2, 3, and you'll see that same information. So I'm just going to be pulling up the document again, just so you can actually compare the text. So if you notice, that place where I'm hovering is the first box that we had created, right? And then the consequent boxes after that, box 2, box 3. So now you can just go ahead and see a comparison, and how the text was actually pulled. And if you notice, it did a pretty solid job at pulling the text out accurately, and with dash lines, right? Because when this is chunked, now if you see this as an output for the LLM, you'll know that the LLM is going to be reading this properly, right? If this wasn't, if we had just put this document through a general text extraction, the output would have been horrible, and feeding something like that to an LLM is just a waste of resources. So that's why you do template extraction. So you can, look at the output here, and in the meantime, I'll just explain that this entire concept, this entire process of creating templates for the different varying documents is something that is used, in enterprise solutions as well, like DocParser, for example. They also have, the user create templates for the different documents. That way, the extraction is near accurate. Um, and it does make sense because look, the template extraction does not take too long. Creating a few boxes, it's pretty quick. And just for that little sake of time, now whenever you have this same structured document show up for you, you will know that the output is going to be accurate, and you won't have to worry about having any misinformation from the LLM output. So I'm just walking through the information here. um, and this is where I am at now. So this is for the RAG solution or the TRAG solution. So the whole point of TRAG, which is temporary memory RAG, is that in a RAG solution, you would be taking this information, chunking it, vectorizing it, and then storing it into a vector database. But that is great when you need to be frequently actually pulling that information. But in an ETL pipeline, you only need to extract text from any given document just once, right? So there's no point in actually storing that into some database. That's why I came up with the idea of just storing that into your temporary memory, right? So that way you are extracting from it once, and then it's gone. So that's why temporary RAG, hence TRAG. So yeah, and of course this is some. And the reason I'm doing this is because the alternate to this is just taking the entire document that you have and uploading it to some existing LLM like ChatGPT, Claude, Copilot, or Grok, right, and expecting it to provide you with the output that you're looking for. The problem with that is, I'm sure you can go ahead and try it out yourself, is that you will have terrible accuracy in the results. You will have to do a lot of prompt engineering, to make sure that you actually get the output that you want. um, and you will always be unsure of whether the LLM has actually properly read your document, because remember, we are creating templates out here for different varying structures, whereas what the LLM is doing is just reading as is, as if it's a normal, like it will have base logic to just read any sort of document, and then it's of course using its own the LLM has its own capability of making sense of that given text, which is pretty good, but it's not perfect, right? And so it's always better to have the text extracted in a proper manner, so that and then feeding that to the LLM, so that your output is always good. So uh, yeah, so the whole point of this is that this is going to be giving you a lot more of an accurate output, as well as it's also going to be a lot more resource efficient. Just because it's a RAG, right? So you're only feeding the necessary chunks as context instead of giving the entire document to it. So yeah, the next steps now are going to be to create the logic for auto detecting the right template, because right now I showed you that it's going in and it's using the template to extract text from any given document. But once you start having multiple documents and multiple templates, it needs to have the ability to detect the right template to use. So what my method right now is to do is that uh, what I'll do is, for any given template, I'm just going to pull all the text from that given template and store that as your signature key for that template. And then what it will do is when we are extracting from a document, we're also going to pull all the text from that document, and then we'll just do a quick comparison check of which template has the most similar text and use that template accordingly. That's not the most efficient approach, but for the sake of bringing this project to the finish line, it's the quickest approach. A more efficient approach that I thought of was to do the same thing, but instead of just storing text as is, we would store that text as a vector and store that into a vector database so that you now have a database of, template vectors. And then whenever you have a new document that you want to extract, you pull the text from that, turn that into a vector, and then pull the nearest template vector and use that, which is far more efficient. Over when we're talking about scaling. So yeah, but yeah, I for the sake of bringing this project to the finish line, I would go with method one. And yeah, that's my next step now. So I hope that gave a good idea of what I'm doing right now. And if you have any questions, let me know. Thanks. Bye.